Welcome back. Let's finish out these last couple of examples, and then you can do the problems to try on your own, and you will be good to go for class next time. All right. To raise money for new football uniforms, your school sells silkscreen t-shirts. Short-sleeve t-shirts cost the school $5 each and are sold for $8 each. Long-sleeve t-shirts cost the school $7 each and are sold for $12 each. The school spends a total of $2,500 on t-shirts and sells all of them for $4,200. How many of the short sleeve t-shirts are sold? So we've got two variables, so we need two equations. If you look, you can kind of categorize your information into two things: costs and selling prices. So we're going to make a cost equation and we're going to make a selling price equation. All right, so you're going to do the cost per shirt for the short sleeve shirts, so $5, times the number of short sleeve shirts, we'll let that be X. And then you're going to add to that the cost per shirt for long sleeve shirts times the number of long sleeve shirts, which we're going to call Y. So we've got 5X, that's the total amount spent on short sleeve shirts, the cost, okay, plus 7Y, that's the total cost for the long sleeve shirts, and altogether, according to the problem, that was $2,500. Okay, now let's do the selling prices. That's going to be equation 2. So we're going to use X and Y again, and we're going to look at how much revenue we're going to get, how much we're going to sell them for. So we're going to charge $8 for each short sleeve shirt, so 8 times X, plus $12 for each long sleeve shirt, so 12 times Y, and that's going to equal $4,200. And so that's just the amount of money they're going to bring in. Okay, now if we wanted to know profit, we'd have to subtract the cost from the revenue. But that's not really what we're interested in. We want to know how many short sleeve shirts we need to get and how many long sleeve shirts we need were ordered, and so we can know how many to order to make this work. So we've got 8X, that's the amount of money that's going to come in if they sell all their short sleeve shirts, and 12Y, that's the amount of money they're going to make from all, or the amount of money they're going to bring in from all their long sleeve shirts, and the total revenue, the amount they're going to get, is $4,200. Now income's the difference between revenue and cost, so you would have to do the $4,200 minus the $2,500, and that's going to give you $1,700. So, but that's really a different lesson. All right, so we want our system of equations, and we want to figure out how many shirts, short sleeve shirts, are going to be sold, and how many we're not asked for how many long sleeve shirts, but we'll probably figure that out along the way. All right, so we've got our two equations: 5X plus 7Y equals 2,500. 8X plus 12Y equals 4,200. So we're going to solve using the elimination method. We're picking the elimination method because we don't have a variable that just has a coefficient of 1 or negative 1. So it'd be a pain to use substitution. All right. Neither variable has numbers that are easy to work with. You can't multiply 5 by something nice to get 8. Or vice versa. You can't multiply 7 by an integer to get 12 or vice versa. So what we're going to have to do is pick a variable. We're going to pick X. Okay, we're going to eliminate X. And we have to, in equation 1, multiply by the opposite of what's in equation 2. So negative 8, because we need to multiply by a negative so that we get different signs. So we're going to multiply equation 1 by negative 8. And then what we're going to do for equation 2 is we're going to multiply by the coefficient of X in equation 1. So we're going to multiply by 5. And that's going to guarantee that we end up with opposite values, numbers that differ only by sign, in front of our X's. Okay, so we're going to multiply equation 1 by negative 8 and equation 2 by 5 so that the coefficients of X differ only in sign. They're opposites of each other. And you'll see this works out really nicely. Okay, so we're going to take all those values and multiply by negative 8 for equation 1. So 5 times negative 8 is negative 40, so we have negative 40x. 7 times negative 8 is negative 56, so we have minus 56y equals 2,500 times negative 8 is negative 20,000. Now we're going to take 8x plus 12y equals 4,200, and we're going to multiply by 5, because that's going to give us a positive 40 in front of the x. So 5 times 8, like I just said, is equal to 40. Excuse that. I'm up here on a Saturday, actually, and the bells are ringing. That's just crazy. sorry about that. 12 times 5 is 60, and then 4,200 times 5 is 21,000. Okay, so now that we have opposites in front of our x values, which is really cool, worked out really nicely, when we add them together, they will zero out. The x will be eliminated. That's why it's called the elimination method. Negative 56y plus 60y is 4y. And negative 20,000 plus 21,000 is 1,000. So to solve for y, we just divide by 4, and that's 250. Now, that's the number of long sleeve shirts. That's not really what we wanted. We wanted the number of short sleeve shirts, but we can find it now. Okay, we're going to substitute the value of y into one of the original equations and solve for x. So 5x plus 7y equals 2,500. Again, it doesn't really matter which equation you plug into. When one's not obviously easier, so that you're not sitting there trying to make up your mind, just go with equation 1. So we're going to substitute 250 for y. So we've got 5x plus 7 times 250 equals 2,500. So 7 times 250 is 1,750. So we need to subtract that from both sides. So we get 5x equals 750. Divide by 5. And you get x equals 150. So 150 short sleeve t-shirts and 250 long sleeve t-shirts. We're interested in the number of short sleeve t-shirts, so the answer is C. Guys, I do want to point out that one of the distractor answers that are incorrect is 250. So if you're not reading carefully, once you get to that y equals 250, you might think, all right, I'm done. So be really careful on really well-written tests that are multiple choice. The distractors, the incorrect answers, are answers that come from doing the problem partially correct or from common mistakes that people make. So be very, very careful. Okay, we're going to go on to example 4. All right, we're going to solve a linear system. I don't tell you what method to use, so it's really up to you. Now, obviously, a method has been picked to work these out, and the reasoning behind it will be explained. All right, so for the first one, we've got x minus 2y equals 4, 3x minus 6y equals 8. You could use elimination on this one, but since there's an x there in the first equation that's just 1, we're going to use the substitution method. You don't have to. Again, on a problem like this, if you just like the elimination method, go for it. But we've only had one example with the substitution method, so it doesn't hurt to see another one. So what we would do is solve the first equation for x by adding 2y to both sides. Okay, write down that first equation, x minus 2y equals 4. Solve for x by adding 2y to both sides. And so you'll have x equals 2y plus 4. Now you're going to write the second equation. You've got 3x minus 6y equals 8. Okay, so now we can substitute that expression for x into this equation. So see the red x and see the red 2y plus 4? That's because we replaced or substituted x with 2y plus 4. So we've got 3 times 2y plus 4 minus 6y equals 8. We're going to simplify. Well, let's distribute the 3. We get 6y plus 12 minus 6y equals 8. 6y minus 6y zeroes out, and we get 12 equals 8. Well, that's a false statement. I mean, all the y's went away. And remember, when all your variables, all of them, leave, you stop and you judge whether you have a true statement or a false statement. This is a false statement. What that means is there are no values for x and y that solve this system. There's no solution. Because the statement 12 equals 8 is never true. It's a false statement. There is no solution. So your answer here is no solution. If you end up with something like 12 equals 12, 8 equals 8, 0 equals 0, that's a true solution, or that's a true statement, excuse me, then that means you have infinitely many solutions. All right, for part B, that was 4x minus 10y equals 8, negative 14x plus 35y equals negative 28. Because there's no coefficient of 1 or negative 1, you're definitely not going to want to use the substitution method, so we're going to use the elimination method. Again, this is one where it's not going to be super duper easy to get opposites for coefficients, but if you look at the 4 and the negative 14, if I multiply 4 by 7, I'll get 28, and if I multiply negative 14 by 2, I'll get negative 28. So that's what I'm going to do, because remember we want opposites, so numbers that differ only by the sign in front of one of our coefficients, as one of our coefficients. So I'm going to take the first equation and multiply by 7, and the second equation and multiply by 2. I didn't need to multiply by a negative this time because the x's have opposite signs. 4x is positive and negative 14x is negative. All right, so I'm going to take 4x minus 10y equals 8 and multiply by 7. And that's going to give me 28x minus 70y equals 56. And then I'm going to take the negative 14x plus 35y equals negative 28. I'm going to multiply that by 2, and that gives me negative 28x plus 70y equals negative 56. And then I go to add them together. Well, 28 plus negative 28 zeroes out. So does negative 70y plus 70y. They both zero out. And look over here. 56 plus negative 56 zeroes out too. So we end up with 0 equals 0. That's a statement that's true. It's always true. So there are infinitely many solutions. That means that if we were to graph these lines, they would graph right on top of each other. They're coinciding lines. And so you have infinitely many solutions. Back in part A, let's go back, where we had no solution. If we were to graph those two lines, those would be parallel lines. Remember, parallel lines on the graph means there's no solution. And then here, where we interpret this as infinitely many solutions on a graph, what this would look like is you would end up with one equation graphing right on top of the other. Okay, guys, you are ready to do the 2 problems to try on your own. Get those done and make sure you bring your notes with you to class so you get credit for it, and then we'll go over the problems to try on your own and get you started on those rounds. Thank you. Have a good day. I'll see you in class.